This is insane. That is exactly how many people reacted when Elon Musk revealed Tesla's newest breakthrough for the Tesla Semi. Because the biggest problem for electric trucks has never been power, it has never been speed, it has always been charging time. Imagine a freight truck carrying tens of thousands of pounds across hundreds of miles. When the battery runs low, every minute spent charging means lost revenue. For logistics companies, time literally equals money. And that is why Tesla's latest semi-charging breakthrough is getting so much attention. According to Elon Musk, Tesla is developing megawatt-level charging technology capable of refueling a massive electric truck in a fraction of the time people expected. If this works at scale, it could completely change the economics of electric freight. Today, we're breaking down what the Tesla semi-charging breakthrough actually is, how fast megawatt charging could realistically be, and why this may be the biggest advantage Tesla has over every other electric truck manufacturer. If you want deep analysis on Tesla innovation, future transportation, and real technology breakthroughs, make sure you subscribe to the channel right now. We break down what the headlines mean and what the technology actually does. Because when it comes to electric trucking, charging speed changes everything. Let us begin. Tesla's megawatt charging system explained. To understand why this breakthrough matters, we need to look at the technology behind it. Tesla calls it the megawatt charging system, often shortened to MCS. And the name already tells you something important. This is not kilowatts. This is megawatts. 1. Why electric trucks need much more power. A normal electric car might charge at 150 kilowatts, 250 kilowatts on Tesla superchargers. That works well for passenger vehicles. But the Tesla Semi is not a passenger car. It carries a battery that could be 10 times larger than a typical electric car battery. That massive battery is needed to move a fully loaded freight trailer across hundreds of miles at highway speeds. If you tried charging that battery using regular car chargers, it would take far too long. And in trucking, long charging times destroy efficiency. That is why Tesla needed something completely different. 2. The megawatt charging system. Tesla's solution is simple in concept, but incredibly powerful. Instead of hundreds of kilowatts, the semi-charging system can deliver over 1 megawatt of power. That means more than 1,000 kilowatts flowing into the battery during charging. To put that in perspective, one single Tesla semi-charger could deliver enough electricity to power dozens of homes at the same time. This kind of power dramatically reduces charging time. Tesla has suggested that a Semi could recover hundreds of miles of range in about 30 minutes. That is a critical number, because 30 minutes aligns closely with legally required rest breaks for trucking drivers in many regions, so charging can happen while the driver rests, not after the route ends. 4. Cooling and cable technology. Delivering megawatt-level electricity creates another problem: heat. Massive power flowing through charging cables generates enormous heat if not managed properly. Tesla's system uses liquid-cooled charging cables to keep temperatures stable. This allows extremely high power levels without damaging the hardware. Without liquid cooling, megawatt charging would not be practical. 4. Why this changes electric freight. Fast charging removes one of the biggest concerns fleet operators have about electric trucks: downtime. If a truck can recharge during scheduled rest breaks, the vehicle can stay on the road without disrupting logistics schedules. That makes electric trucking far more competitive with diesel. But even with megawatt charging, one major challenge remains: infrastructure. Before we explore that, make sure you're subscribed if you enjoyed deep dives into Tesla technology and the future of transportation. The infrastructure battle: charging a fleet of electric trucks. Now that we understand Tesla's megawatt charging technology, the next challenge becomes clear. Building the chargers is only half the battle. Deploying them everywhere trucks operate is the real test. Because electric trucking only works if the charging network grows alongside the vehicles. 1. Why truck charging is harder than car charging. Passenger cars usually charge at homes, parking garages, public supercharger stations. But freight trucks operate very differently. They travel long highway corridors, international routes, industrial logistics hubs, shipping ports, and distribution centers. A truck cannot simply pull into a crowded car charging station. It needs space, a lot of space. Large trucks require wide turning radius, long parking areas, and heavy-duty electrical connections. That means truck charging infrastructure must be built differently from normal EV charging stations. 2. Tesla's Megacharger network. Tesla's answer is something called the Megacharger network. These are ultra-high power charging stations specifically designed for electric trucks. Megacharger stations will likely include megacharger cabinets, large truck parking bays, and dedicated fleet charging areas, high-capacity grid connections. Unlike passenger chargers, these sites are designed for logistics operations. Some might even be built directly at freight depots, warehouse hubs, and distribution centers. This allows fleets to charge trucks during normal loading and unloading operations. 4. Why energy supply becomes critical. Megawatt charging uses enormous amounts of electricity. Imagine a station with 10 Tesla semi-trucks charging simultaneously. That could require 10 megawatts or more of power. That level of electricity demand requires major grid upgrades, high-capacity transformers, and advanced energy management systems. Tesla has experience here because the company also builds grid-scale batteries, solar energy systems, and energy storage infrastructure. This gives Tesla an advantage. They are not only building trucks, they're building the energy ecosystem that powers them. Now here's the big question. Even if megawatt charging works perfectly, can Tesla build enough infrastructure fast enough to support thousands of electric trucks? Before we answer that, make sure you're subscribed if you enjoy deep dives into Tesla technology and the future of transportation. Why logistics companies are paying close attention. Now let's talk about the people who matter most in this story. Not Tesla fans, not technology enthusiasts, but fleet operators and logistics companies. Because these companies make decisions based on numbers, not excitement. If Tesla Semi and megawatt charging improve the economics of freight, adoption could happen much faster than people expect. 1. Fuel is one of the biggest costs in trucking. For most freight companies, diesel fuel is one of the largest operating expenses. A single long-haul truck can burn thousands of gallons of diesel every year. When diesel prices rise, profit margins shrink immediately. Electric trucks offer something diesel cannot provide: energy price stability. Electricity prices are generally more predictable than oil prices, and if companies generate electricity using solar energy or other renewable sources, operating costs could fall even further. This makes electric trucks very attractive from a financial perspective. 2. Maintenance costs drop dramatically. Diesel trucks are complex machines. They require constant maintenance such as oil changes, transmission servicing, exhaust system repairs, and engine component replacements. Electric trucks remove many of these systems entirely. The Tesla Semi uses electric motors with far fewer moving parts. Fewer moving parts usually mean fewer mechanical failures. For fleet operators, that means less downtime and lower repair costs. And in freight logistics, downtime is extremely expensive. A truck sitting in a repair facility is a truck that is not generating revenue. 3. Driver comfort matters too. Another factor logistics companies consider is driver satisfaction. The trucking industry has struggled with driver shortages for years.
Tesla designed the Semi with a very different cabin layout. The driver sits in the center of the cab, with excellent forward visibility. The truck also offers advanced driver assistance systems, smooth electric acceleration, and reduced cabin noise. These improvements may help attract drivers who prefer a more modern driving experience. 4. The real test: long-term reliability. However, fleet operators are cautious. They won't replace diesel trucks overnight. They want proof. They want to see real-world durability, long-term battery performance, and charging network reliability. Early Tesla Semi deployments with companies like Pepsi are already generating valuable data. If those trucks perform well over hundreds of thousands of miles, confidence in electric freight will increase dramatically. Now we're approaching the final question: is Tesla's charging